Welcome back to the session. In continuation with the previous session, we shall solve some more numerical problems pertaining to centroid. So here is the area for which we are supposed to calculate the centroid. So this is the shaded portion. We shall mark the origin. The origin is mentioned in the lamina itself. The radius of the quadrant is 30 mm. Again, the radius here is 30 mm. So now, what we are supposed to look for to start with? We are supposed to look for the axis of symmetry. So where does the axis of symmetry lie for this particular component area? It is neither on the x-axis nor on the y-axis. So then we are supposed to calculate both x bar and y bar with the subsequent coordinates. So for that we shall mark the basic shapes looking on to the overall area given. For that we can just observe here we do have a rectangle. So then we shall mark the rectangle as the first basic shape. Inscribed is a quadrant of a circle, that would be the second basic shape. The next one is the quadrant of a circle again. So now we are supposed to calculate the areas individually first. So firstly, the area of the first basic shape, that is the rectangle, as the radius is mentioned as 30 mm, we shall write the area of the rectangle first. So now we shall write the area of the rectangle as 30 by 30 first. Next, area of the second basic shape, that is the quadrant of a circle. It is pi, r is 30 square by 4. The next area is the quadrant of a circle again with the radius 30 mm. So it is pi, r is 30. So it is pi r square by 4. One thing that we will have to notice here is that a quadrant of a circle is to be removed out from the entire area. Means to tell that this particular area will be considered as negative, because in order to get the shaded portion, we'll have to scoop out this area from the, we'll have to scoop out this area, that is the quadrant of a circle, from the entire area. So now we have marked the reference axis, right? So we shall just highlight the reference axis so that we may not get confused with the sign conventions. The next important thing to be noticed in this particular problem is that we have a basic shape to the left of the axis also. Means that we have to give consideration for the sign convention. That is, whatever the centroidal points that we mark to the left of the axis will be considered negative. So now, the next thing is that we'll find out x1, x2 and x3. For that, we shall mark the points individually. So, this is the first area, means to tell the rectangle, right? So, in order to find out all the points related with x, we'll consider y as the reference axis. As of that, the first point, that is the centroid for the first shape, lies here. We shall just write that as G1. Fine. So now, taking y as the reference axis, here is the point. So this is x1. So we'll have to write that as 30 by 2. So it is 15. So but we'll have to see that we have this point to the left of the axis. So it is to be prefixed with a negative sign as per the sign convention, that is the basic sign conventions whatever we follow during the resolution of the forces. Basically that whatever we have learned during the startup of the sessions. So now x2. So we shall just mark the point x2 being this as the second basic shape. So let us just write here would be the centroidal point, taking x as the reference. So here is the distance we'll have to consider. So this is 4r by 3 pi. As per the derivation, where does the centroid for the quadrant of a circle lie? It lies at a distance of 4r by 3 pi. So again, we have the point to the left of the axis. So we are supposed to prefix with a negative sign. Fine. So that is very important to identify. Above all, do we have to consider only 4r by 3 pi? No, because this portion is inscribed within a rectangle. We'll have to consider the overall distance. To that, we'll have to subtract 4r by 3 pi. So here I write 30 minus 4r by 3 pi. Fine. To that, fine. Again, what is the next thing that we are supposed to consider? It is the negative sign, right? So, from the overall area of a rectangle, we are considering only the quadrant of a circle. So, this is the rectangular distance. And we are subtracting with 4r by 3 pi, prefixed with a negative sign as it lies to the left of the axis. I have just highlighted it with a color chalk piece. Fine. I have highlighted it with an orange color so that we just don't get confused with the things. Next, moving on to the next basic shape. So we are marking the centroid here. So where does the centroid lie? Taking y as the reference, the centroid lies at a distance of 4r by 3 pi. Do we have to prefix it with a negative sign here? Not necessarily, because the point is after the axis, so it is positive itself. So here is how we calculate x1, x2 and x3. Moving on to the next. It is y1, y2 and y3. So again we shall just mark y. For the first point, taking x as the reference, what is y1? So it is 30 by 2, as it is a rectangle. Next, for the second point, here is the y1. For the next section, so this is the centroid, so we shall mark y2 as such. So now we are supposed to consider that as 30 minus 4r by 3 pi. So here is the y2. Again we know it is, the quadrant of a circle is inscribed within a rectangle. The rectangular area is, the base of the rectangle is 30 and we are subtracting the 4r by 3 pi with that. Fine. Next, y3 again here is from x-axis till this point is y3. So it is 4r by 3 pi. So this is how it goes. Now moving on to the very important thing, that is to calculate x bar. We know it is a1 x1, next is a2 x2 and a3 x3. a1 plus a2 plus a3. We'll have to see whether any area has to be considered negative here. Yes, of course, we'll have to consider the area which is not shaded as negative. Fine. So now we can see that this second part, that is the quadrant of a circle, has to be considered negative. So we shall notice that the second area is to be considered as negative. Remaining, that is the other two portions which is not shaded, is considered positive itself. So here we will have to see that this area should be prefixed with a negative sign. Similarly, here the area, that is the second area, is to be prefixed with a negative sign. Fine. So I have just highlighted it as such, so as to avoid any confusion. Fine. Similarly, to calculate y bar, it is a1 y1, a2 y2 plus a3 and y3, a1 plus a2 plus a3. The area related with the second component has to be considered negative. So it has to be prefixed with a negative sign, and the same here with the new denominator. So now we get the values of x bar and y bar. Upon substitution, we get the value of x bar as 8.562 millimeter and y bar we get as 11.438 millimeter. So this is how it goes. Moving on to the next problem. Determine the centroid of the shaded area with reference apex. A triangle inscribed with a semicircle, a rectangle and a circle. So, the base is 160 mm. The radius of the semicircle is 40 mm. The base of the rectangle is 60 mm. Radius of the circle is 40 mm. So, we shall mark the dimensions here. The dimensions are given. So, this is the lamina given and the shade will be as such. So, now we shall find out what are the basic shapes that are given here. Before that, we know that axis of symmetry is on y axis. So, means to tell the centroid of all the basic shapes lies on y axis, right. So, that the big triangle will be the first shape, second is the semicircle, a rectangle and the circle. So, what is the area of the first section? So, that is area of the triangle half into base is 160 into height is 1, 2, 3, 4 and 5 and 6. 6 4s are 24, it is 240 mm. So, this is the area of the bigger triangle. Next, area of the second section. So, it is a semicircle. Pi r is 40 square by 2. Area of the second section. Area of the third section, it is a rectangle. So, 60 by 40. We can just see it is So now the area of the rectangle is 60 by 40. Lastly, area of the circle is pi r square. We will have to make sure that we are prefixing negative sign for the unshaded basic shapes, that is for the circle, the rectangle and the semicircle. Fine. Next is we will find out x1, x2, x3 and x4. Moving on to the next problem. So now we just observe this entire area. We have a triangle which is shaded and inscribed with a circle, rectangle and a semicircle. So means to tell, from the entire area we will have to remove these three basic shapes, so that we should know that the area of the three sections has to be considered as negative. So now the area of the first basic shape, that is the triangle. Triangle is the first area. Half into base is 160 into height is 240. Next, second section is a semicircle. So the area of the semicircle is pi r square by 2. Area of the rectangle is 60 by 40. Area of the circle is pi r square. We'll have to notice here that the three areas, that is second, third and fourth, will have to be prefixed with a negative sign. Next, to find out x1, x2 and x3. Next, we'll have to find out y1, y2 and y3 and y4, because the entire section is symmetric about y-axis, means to tell the centroid lies on y-axis. So now the centroid for the first section, that is the triangle, lies at a distance of h/3 from the base. So what is the overall height? It is 240 divided by 3, because the centroid for the symmetric triangle lies at a distance of h/3 from the base. That is what we have written it here. Next, this is the second section. So I just mark the second section. Here is the semicircle. So where does the centroid for the semicircle lie? It lies at a distance of 4r by 3 pi. 4r is 40 by 3 pi. This is what is shown here. Next is the centroid of the third section. So here is the third section. So we'll have to consider from the base till the centroid of the third section. So we'll have to mark 40. This is 40 plus 40 plus the centroid of the rectangle. It is 40 by 2. Fine. Next, the last section, that is the circle. So the centroid will be here. All we have to consider this distance. So again it is 40 plus 40. Again here it is 40 plus 40 plus this is the centroidal point, that is 40 again. It is 40 by 2, right? So here is the points y1, y2, y3 and y4. Next, in order to find out y bar, we will have to write this a1 minus y, a1 into y1 minus a2 into y2 minus a3 into y3 minus a4 into y4 divided by a1 minus a2 minus a3 and minus a4. Upon substituting all these values, we get y bar as 82.02 millimeter. So, but in the question they have mentioned to determine the centroid of the shaded area with reference apex. So, this is the reference apex, right? So, what is the overall height? It is 240 mm. Therefore, the distance from apex, that is the reference apex, is equal to 240, means the overall height, minus y bar, that is 82.02. We get 157.98 millimeter. Here it goes. Moving on to the next problem. So now this is the given area. So it is divided into one triangle, two rectangle, three triangle, that is a right angle triangle again. Again it is divided into a rectangle. So we can just see the whole area is divided into four different sections. You can just observe it here. 1, 2, 3 and 4. So now we shall see about the axis of symmetry. We don't have the axis of symmetry either on x-axis or on y-axis. Means to tell that we are supposed to find out both x bar and y bar. Before that, we shall find out the areas of all four sections individually. Area of the first section. So this is the first section, a right angled triangle. So it is half into base is 2 meter into height is 6 meter. Next, area of the second section. So this is the second section. Here is the second section, a rectangle. So it is 2 by 1.5 plus 6. It is 7.5. Next, area of the third section. So the third section is a right angled triangle again. So half into base is 5 into height is 6 minus 1. We can just observe, we will have to deduct this overall height, that is 6 meter with 1 meter. So, it is 5 again. Next, area of the fourth section, that is the rectangle. It is 5 plus 1. 6 is the base and height is 1 meter. So, it is 6 by 1 meter. Next, moving on to finding out values of x1, x2, x3 and x4. So, now the first point, that is considering this as x-axis and again here as the y-axis. For the first section, we shall mark the centroid here. So, to find out x1, y will be the reference axis. So, from y, we are supposed to consider this as x1. So, this is x1. As we know, here is the right angle triangle. This distance is b by 3 and the remaining distance is 2b by 3. So, where does the centroid lie with respect to y-axis? It is at a distance of 2b by 3. 2 into b is 2 by 3. We can just observe it here. Next, x2. We will mark x2 here. Somewhere here we shall mark as x2 so that we don't get confused. So, this is x2. So, we will have to consider it as 2 plus 2 by 2. As it is a rectangle, it is 2 by 2, right? Because we have 2 meter here. So, to find out the centroid of a rectangle, it is 2 by 2. Next, the third section, the centroid will be here. We will be marking the centroid here. So, from y-axis till this point is x3. For that, 2 plus 2 plus, we can just look here, this is b by 3 and the remaining would be 2b by 3. So, it is 2 plus 2 plus b by 3. So, what is b here? 5 by 3. Fine. Next, for the last section, the centroid will be marked here. So, the distance is from here to this point. This is x4. So, therefore, it is 2 plus 2 plus, we can just see it is a rectangle. So, 5 by 2. This is the x4 value, 2 plus 2 plus centroid of a rectangle. Fine. So, now moving on to the y bar, that is points required to find out y bar. It is y1, y2, y3 and y4. First of all, y1. Now, we will have to consider x as the reference axis. So, which is the first section? This is the right angle triangle. So, from here to x axis, this is h by 3 and the remaining portion is 2h by 3. So, it is 2h by 3. 2 into height of this is next is to find out y1. So, taking x as the reference axis, y1 is h by 3. So, what is h for this right angle triangle? It is 6 by 3. Next, y2, the rectangle, the centroid with respect to x axis, it is, so the height here is 7.5 by 2. Moving on to the third section. So, this is y3. So, it is 1 plus h by 3. 1 plus the height of this is 5 meter, 5 by 3. Why we are considering it as 5? Because this overall height is 6 meter, because we have 1 meter here. So, but now we will have to consider the height as 1 plus 5 by 3, right. Next, the last one is 1 by 2. So, these are the points of y1, 2, 3 and 4. Upon substituting all these values in the expression x bar as summation of ax by summation of a and y bar noted as summation of ay by summation of a, we get the value of x bar as 4.19 meter and y bar as 2.64 meter. Fine. Next, moving on to the next problem. Moving on to the next problem. We are supposed to locate the centroid for the given area. (20 millimeter). The radius is 40 millimeter. The overall height is 70 millimeter. So, the height here is 40 millimeter. This is the point of origin. So, we can just observe here we have 3 sections, of which we have one rectangle, 2 right angled triangle and a quadrant of a circle, of which we'll have to consider the quadrant of a circle which is not shaded as a negative area. And one more thing that we'll have to see here is that as the origin is mentioned here and all the section, that is the entire area, lies in the first quadrant itself, so we are not supposed to worry about the negative sign for the subsequent points or the coordinates that we require to find out x bar or y bar. So now the area of the first section. So the area of the first section is a rectangle. So it is 40 plus 20, 60 into height is 40. Area of the second section is a right angled triangle. Half into base is 60 into height is, base is 30 into height is 60. Area of the third section. So third section is a quadrant of a circle. We will have to consider it as negative, minus pi r square by 4. So now moving on to finding out the x bar and y bar. So x1, x2 and x3. So to find out all the coordinates for the individual sections, we consider y as the reference axis to find out x1, 2 and 3. So taking this as a reference, as we know the first section is a rectangle, the centroid will be marked here. So now this is x1, means to tell it is 60 by 2, because here it is 40 plus 20. So 60 by 2 is the centroid of a rectangle. Next, x2. Where does the centroid for a right angle triangle lie? So here is the x2. So this is h by 3 and the remaining would be 2h by 3. So 2 into h is 60 by 3. The last one, that is the quadrant of a circle, is 4r by 3 pi. But this quadrant is inscribed within a rectangle. We'll have to deduct that distance. So it is 60 minus 4r by 3 pi. So now x3 is the centroid for the third section, taking y as the reference axis. Therefore, the quadrant of a circle lies at a distance of 4r by 3 pi. So now we get the values of x1, x2 and x3. Similarly, y1, y2 and y3. So now for the first section, taking x as the reference axis, it is 40 by 2. 40 by 2. Next, y2. You can just see here is y2. Therefore, it is 40 plus b by 3. 40 plus base is 30 by 3. Next, y3 is this 4r by 3 pi. Upon substituting all these values in the expression of x bar and y bar, we get x bar as 42.41, 42.41 and y bar as 35.07 mm. See, but the thing we'll have to notice here is that, as we know, we'll have to consider the quadrant of a circle, that is the area of the quadrant of a circle, as negative. So just I'll write it here. X bar is equal to A1 x1 plus A2 x2 minus A3 x3 by A1 plus A2 minus A3. That is what we have shown it here. Similarly for y bar, we consider the area of the third section. I am highlighting it is not the coordinates of the individual sections, it is the area of the section we will have to consider here if we are concerned with the origin. Fine. If we are concerned with the shaded area, so the unshaded area will be considered as negative. So that particular area will be considered negative and not the coordinates. So when are we concerned about the coordinates? If and if at all, if the origin will be, if the axis will be marked here. So now moving on to the next problem. So moving on to the next problem. So we shall mark the basic shapes: 1 rectangle, 2 right angled triangle, 3 circle and a semicircle. So here the radius is 50 mm. So we shall find out the areas individually. Firstly, the area of the first shape, that is the rectangle, it is 100 by 50. Area of the second section, it is a right angled triangle, half into base is 50 into height is 50. Area of the third section, that is the circle, it is pi r square, r is 25. Area of the last one, that is the semicircle, so the radius is 50 square by 2. We will have to note here that the circle is to be considered as negative because that is unshaded shape. So the circle has to be considered negative here. The next important thing we'll have to notice here is that we have the point of origin here. So means to tell, here is the x-axis and the y-axis. Fine. So as per the sign convention, we'll have to consider the portion below the x-axis as negative. Means to tell, the area is not negative there. The coordinates would be considered as negative, right? Next, finding out x1, x2, x3 and x4. What is the value of x1 considering y as the reference axis? It is 100 by 2. Next, x2 is here. So taking y as the reference axis from y till this point, so this is the right angled triangle. So this is h by 3, this portion. So what is the height of this right angled triangle? It is 50. So we will have to consider it as 100 plus 50 by 3. Next, x3 is here. So we will have to consider from y axis till this point. Therefore it is 100 plus 50. 100 plus 50 because the circle is inscribed within a semicircle which has the radius of 50, right? So now x4 is 100 plus 50. Now moving on to the coordinates of y. Taking x as the reference axis, y1 is this. So 50 by 2. y2 is, taking x as the reference, we are having y2 here. Therefore it is 50 plus, we can just see b by 3. So b is 50 by 3, right? Next, y3, taking y as the reference here, y3 is this point. So it is 25. It is 25. Now so y4 is here. From x as the reference, we will have to consider this. Therefore it is 4r by 3 pi. Radius is 50. Very important, we will have to note here that we have this section below the axis. So that point will be considered negative, means y4 is to be prefixed with a negative sign as that ordinate lies below the axis. Now, upon substituting all the values in the expression of x bar as a1 x1 plus a2 x2 minus a3 x3 plus a4 x4 divided by a1 plus a2 minus a3 plus a4. Sorry, here it is x4. Again in y bar a1 y1 plus a2 y2 minus a3 y3 plus a4 y4 divided by a1 plus a2 minus a3 plus a4. Why we have considered negative area for the third section? Because the third section, that is a circle, is unshaded. See, we will highlight here, area is negative, not the ordinate. So, upon substitution of all those values, we get the value of x bar and y bar as 1125.5 millimeter and y bar as 19.6 millimeter. This is how it goes.